How do you cross one of the most challenging mountainous regions in the country at over 160 kilometers per hour? The El Insurgente train is the answer. In this video, we explore the inner workings of this technological marvel and the technical challenges that nearly halted its operation. Discover the secrets behind the construction that is positioning Mexico at the forefront of global rail development. The Mexico City-Toluca highway is one of the busiest and most dangerous in Mexico due to its curves and rugged terrain. Given the heavy traffic between these two major cities, and the time this journey takes by car or bus, a modern, fast, and efficient mode of transportation has been essential for decades. Finally, on February 2nd, that El Insurgente's intercity train was fully inaugurated. Spanning almost 58 kilometers and reaching speeds of up to 160 kilometers per hour, this train is more than just a form of mass transit. It is one of the most complex railway engineering projects in Latin America. A project that defied gravity with dizzying viaducts, drilled through mountains using cutting-edge technology, and faced political and economic obstacles that threatened to halt it completely. But how do you build a railway on 30-meter-high columns? How do you drill through 4.7 kilometers of solid rock in a seismic zone? And most importantly, what did it take for this steel giant to finally come to life? Welcome to this journey into the heart of Mexican infrastructure. Today, we analyze step by step, from the foundation to its commissioning, the technology behind its elevated tracks, the secrets of the twin tunnel in the Sierra de las Cruces, and the monumental challenges that made this project a milestone of modern engineering. Get ready, because we are about to discover how Mexico's new railway pride was built, the Insurgente train. This is how the Insurgente train was built. General information. To understand the magnitude of El Insurgente, we must look at the figures that bring it to life. The project spans a total length of 57.7 kilometers, divided into two very distinct geographical areas, the Toluca Valley and the Valley of Mexico Basin, connected by the Sierra de las Cruces mountain range. The system has 7 strategically located stations. In the state of Mexico, we find the Zinacantepec terminal, followed by Toluca Centro, Metepec, and Lima. Upon entering Mexico City, the train reaches the Santa Fe, Vasco de Quiroga, and finally, the Observatorio terminal, which will become one of the most important multimodal transfer centers in the country. But what runs on these tracks? State-of-the-art electric trains manufactured by CAF. Each unit consists of 5 cars, with a total capacity of 719 passengers. These trains are capable of reaching a maximum speed of 160 km per hour, although their average commercial speed is 90 km per hour, allowing the entire journey to be completed in approximately 39 minutes. This represents a staggering time saving compared to the 2 hours the journey can take by road during peak hours. Delving into the technical details of these trains reveals cutting-edge engineering designed in Spain but specifically adapted to Mexico's terrain. The model is the CAF Civia, a multi-unit electric train platform renowned for its versatility. Each train is powered by asynchronous AC traction motors, fed by a 25,000-volt overhead line. But what's truly impressive is its energy management system. The train features regenerative braking. This means that during braking or on long descents from the Sierra de las Cruces toward Santa Fe, the motors act as generators, returning electrical energy to the grid for use by other trains ascending the mountain, drastically optimizing energy consumption. As for safety, the braking system is redundant, combining pneumatic disc brakes and electric brakes. All of this is managed by the ERTMS Level 2 system, a European railway signaling standard that allows the train to be monitored in real time, ensuring that it always maintains a safe distance between cars automatically. Inside, the design prioritizes ergonomics and accessibility. The cars feature wide intercirculation aisles, zoned air conditioning, dedicated spaces for wheelchairs and luggage racks, designed with passengers traveling to the bus terminal in mind. The seating arrangement and LED lighting create an atmosphere of comfort that rivals that of European high-speed trains. All this technological deployment required an investment exceeding 100 billion pesos. A cost justified by the complexity of its infrastructure, from elevated viaducts averaging 20 meters in height, to a deep twin tunnel and cable-stayed sections designed to protect the area's natural environment. The idea of a train connecting Toluca with the capital is not new, but the project we know today officially came to life in 2014. Between 2015 and 2018, construction progressed steadily in the state of Mexico, where the elevated viaducts began to transform the landscape of Avenida Solidaridad Las Torres. But upon reaching the border with Mexico City, the project faced a series of legal injunctions, changes to the original route, and budget adjustments that slowed its progress. With the change of federal administration in 2018, the project entered a phase of in-depth evaluation. After analyzing the investment already made, it was decided to continue construction, but with a renewed focus on the connection to the Santa Fe area and the Observatorio terminal. It wasn't until September 2023 that the first operational phase, formerly named El Insurgente, was inaugurated, serving the 4 stations in the state of Mexico. Finally, after completing the most rigorous testing in the tunnel area and on the complex viaducts of the capital, the system fully opened its doors on February 2, fulfilling a long-standing commitment to the region's mobility. Construction of the elevated viaduct. Building a railway line that can support trains weighing hundreds of tons at speeds exceeding 100 km per hour is no easy task, especially when most of the route is elevated. The El Insurgente Viaduct is a masterpiece of prefabricated engineering. It all begins underground. Due to the varying soil conditions between Toluca and Mexico City, deep foundations were used, employing reinforced concrete piles that, in some places, reach depths of tens of meters to find firm ground. The columns, circular or rectangular elements designed to withstand not only the weight of the train but also the lateral forces of earthquakes, so common in this region, were erected on these foundations. To build the elevated viaduct, a key piece of engineering was used, the self-launching formwork. Imagine a giant mobile structure that walks on the columns. This system allows the concrete for the roadway to be poured continuously as construction progresses. What previously took weeks with traditional formwork, the self-launching formwork accomplishes in just a few days. But its greatest advantage is social. It allows the viaduct to be built without stopping the flow of traffic on the avenues below, minimizing the impact on the city. However, the challenge increases in areas with sharp curves, such as the urban section in Mexico City. Here, the key player is the segment launcher. This machine is capable of assembling prefabricated concrete pieces, called segments, without the need for external cranes. The launcher uses the already constructed viaduct itself as a support to move forward, assembling the roadway piece by piece in the air. But building at this scale is not without risks. In April 2024, an 800-ton launcher collapsed near the Tacubaya Dam. Although the equipment was rendered completely unusable, fortunately, no one was injured, reminding us of the complexity and constant danger of these megaprojects. The geological challenge, the Sierra de las Cruces twin tunnels. If the elevated viaducts are the visible face of El Insurgente, the Sierra de las Cruces twin tunnels are its most colossal hidden feat to cross the natural barrier separating the Toluca Valley from the basin of Mexico. It was necessary to drill 2 parallel tunnels, each 4.7 kilometers long. Unlike tunnels excavated using traditional methods, cutting-edge technology was used here, a monumental tunnel boring machine, TBM. Nicknamed the La de la Paz. This machine didn't just dig through rock, it functioned as a mobile underground factory. At the front, a rotating cutter head crushed the material, while at the rear, hydraulic arms precisely placed precast concrete rings, leaving the structure finished and sealed instantly. But the geology didn't make it easy. The tunnel passes through a highly complex volcanic zone, marked by faults, fractures, and, above all, water. At several points, engineers faced significant leaks that had to be controlled through high-pressure cement injections to stabilize the ground before the machine could pass. Each of the two tunnels has a diameter of 8.5 meters, and they are connected by cross passages every 500 meters, a vital feature for safety and emergency evacuation. Finally, after 18 months of uninterrupted work and the use of the most advanced technology, the engineers succeeded in excavating the entire tunnel. The moment of the final breakthrough was historic. On the other side of the mountain, a group of officials, including the Secretary of Communications and Transportation, along with the team of engineers and workers, waited with cheers and applause as the TBM's cut ahead emerged for the first time. They had conquered the mountain, paving the way for Mexico's railway future. Steel structures, defying the terrain. Although concrete dominates most of the route, there are specific points where the terrain's challenge demanded a different solution: steel. These are the steel structure bridges, designed to span deep ravines and areas of extreme logistical complexity. Cable-stayed bridge. The most emblematic example is the cable-stayed viaduct in the Santa Fe Spring area. Here, the engineering had to be surgical. To avoid damaging the natural environment and to respect the freshwater spring, a cable-stayed design was chosen. To support this giant, two main towers reaching up to 75 meters in height were erected. From them, 8 harps emerge, distributing a total of 104 steel stays. Each of these cables contains dozens of high-strength steel strands inside, designed to absorb the train's vibrations and withstand Mexico City's seismic dynamics. The construction of these steel bridges is a process of millimetric precision. Unlike concrete, which is poured or assembled by segments, these structures are manufactured in specialized workshops, transported in monumental sections, and assembled on-site using X-ray-tested welds and high-strength bolting. Arch bridge. We reach one of the most critical and impressive points of the project: the steel arch. A 2,000-ton mass of steel designed with a clear purpose: to bridge a 100-meter span without interrupting the freight rail lines crossing underneath. It's not just a matter of size, but of precision. This structure utilizes a state-of-the-art tied arch system. To guarantee absolute stability, the design integrates 8 harps composed of high-strength steel strands, making it one of the safest and most modern railway crossings in the world. But the true challenge was its installation. Due to the complexity of the terrain, engineers opted for a master maneuver. The arch was built in 3 sections, which were lifted by 2 gigantic cranes. This required perfect coordination to place the heavy structures, each weighing over 800 tons, onto temporary supports that were finally dismantled once the structure was complete. A landmark of civil engineering that today strategically connects Mexico City with the state of Mexico, allowing El Insurgente to literally fly over the obstacles of the landscape. Stations, hubs of connectivity. With the tracks and tunnels completed, the project needed its points of contact with the public, the stations. These were conceived not just as stops, but as high-flow logistical nodes, designed to be functional, safe, and aesthetically modern. The construction of El Insurgente's 7 stations followed a modular logic. In the State of Mexico section, stations like Zinacantepec and Metepec stand out for their expansive metal roofs that protect platforms from the elements. Their main structure is based on large-span steel frames, allowing for open concourses where thousands of passengers can circulate freely every hour. A highlight of the planning was the inclusion of the Vasco de Quiroga station. This stop was not part of the original project but was strategically added to provide direct access for local residents and university students. With this decision, the project became more democratic and accessible, ensuring the train's benefits reach local communities, not just those traveling from terminal to terminal. On the other hand, Santa Fe Station, suspended over viaducts, required extreme logistical planning as it is surrounded by corporate offices and residential areas. Here, every piece of the facade had to be hoisted with precision cranes during night shifts. But the true crown jewel of connectivity is the Observatorio terminal. This imposing building, with its glass facades and avant-garde architecture, is more than just a train station. It is a full-scale CETRAM, the Spanish acronym for Modal Transfer Center. Its design ensures that the transition between transport systems is nearly seamless. Just steps from the intercity train platforms, users find a direct connection to the Mexico City Metro, the engine that will take them to any corner of the capital. But the intermodality doesn't end there. Less than 100 meters away is the Western Bus Terminal, the gateway for those traveling to various cities across the Republic. Additionally, the integration of urban bus stops in the immediate vicinity ensures a constant and efficient passenger flow. Observatorio thus establishes itself as one of the most important neurological points in the country, where the modernity of El Insurgente joins Mexico's largest transport network to move thousands of people every day. The inauguration, a historic milestone. February 2, 2026, will be marked in the history of Mexican infrastructure. After more than a decade of technical, geological, and financial challenges, the El Insurgente's interurban train finally opened its doors in its entirety. What began as a drawing on paper is now a reality of steel and concrete pulsing through the Sierra de las Cruces. The inauguration was not just a ribbon-cutting ceremony, it was the culmination of a monumental effort involving thousands of engineers, laborers, and specialists. Seeing the train glide continuously from Zinacantepec to Observatorio for the first time represents an unprecedented technological leap for passenger rail transport in our country. The social impact is immediate. Thousands of families who once spent up to 4 hours a day commuting now have a safe journey of less than 40 minutes. This translates into more quality time, less stress, and stronger economic integration between the state of Mexico and the capital. Furthermore, as a 100% electric system, El Insurgente contributes significantly to reducing emissions, taking thousands of cars and buses off the road every day. Building the El Insurgente train was an engineering odyssey that reminded us that, even against the roughest terrain, technical capability and the will to connect will always find a way. Today, this iron giant does more than unite two valleys, it carves the path toward a more modern, efficient, and connected Mexico. Because that is how it was planned, that is how the obstacles were overcome, and that is how El Insurgente was made in Mexico. If you enjoy engineering content, please support us by liking, subscribing, and sharing. What other major Mexican infrastructure projects are you interested in? Tell us in the comments below.